Here's another homework problem from homework number 13, chapter 5. It says, in an analysis of preliminary test results from gender selection method, 43 babies are born, and it's assumed that 50% of babies are girls. And then they're telling us that n equals 43 and p equals 0.5. P is going to be the probability of having a girl, a success. Therefore, Q, we know, is going to be its complement. The probability of not having a girl, or in this case a boy, is also going to be 0.5. And we are asked to find the mean, the standard deviation, and the maximum and minimum usual values. Okay, so we're trying to find these cutoff points of when things get unusual. And so, as we learned in class, we can figure out the mean. The mean is going to equal n times p, which should make sense. You have 43 babies, half of them are girls, or the probability of a girl is half, so you'd assume the mean would be half. So that's exactly what happens. The mean is going to equal 43 times 0.5. 43 times 0.5. My pen is being funny here. And that is going to work out to be 21.5. So the mean number of girls in a set of 43 babies would be 21.5 girls. Okay. All right. What is the standard deviation? Well, the standard deviation we learned, the formula is the square root of n times p times q. So in this case, it's going to be the square root of our 43 times our 0.5, which is p. That's the 21.5 times another 0.5. Make sure that you do the multiplication first, and then at the end you take the square root of all of that. And you will find the value is 3.28 girls. So, all right, so this is an opportunity for us to do a quick review of usual and unusual. This is where we tie in now. We're going to create our normal distribution curve just so we can visually see things. We know that the mean here is 21.5 girls. So 21.5. X down here represents number of girls. That doesn't change. Up here, and the curve is our z-score. So in this case, at the mean, the z-score is 0. All right. What are our maximum and minimum values? Well, if you recall, that's where we hit two standard deviations above the mean and two standard deviations below the mean. That it's outside of those where things start to get unusual, unlikely to happen. What are those numbers in the case of 43 births? Where would it become unusual to have so many girls, or not so many girls in this case? So what we really need to find is this value here and this value here. Well, we know the standard deviation now is 3.28 girls. So if this is 2 standard deviations away, it's going to be 2 times that 3.28, right? And then we're going to add that to the 21.5 going this way and subtract it from the 21.5 going that way. All right, so we'll go over to the side here. What is 21.5 plus 2 times 3.28? And what is 21.5 minus 2 times 3.28? 2 standard deviations above the mean, 2 standard deviations below the mean. Use your calculator to do that work. And we will get 27.56 for our maximum and 14.44 for our minimum. So those are our boundaries there. And what does that mean? It means if you have 43 births, if you have more than 27.56 girls, that would be unusual. So in other words, if you hit, say the question was, would it be unusual to have 30 girls out of a set of 43? And the answer would be yes. It would be unusual here. Would it be unusual to have, say, 16 girls out of a set of 43? 16 girls. Nope, that's still inside the 14.44. Our line is here, 14.44. So no, that would not be not unusual. Okay, so these are our cutoff marks, 27.56. And I know you can't have 0.56 of a girl or 0.44 of a girl, but that's just where your line is. 27 girls would not be unusual. 28 girls would be unusual. So those are your limits. Okay, so give that question a try.